my screen visible to everyone? Is it visible? Okay. I think it's visible to everyone. Hello, Ayush.
Yeah, it's visible.
Okay, okay. That's perfectly fine. Then yeah, so thank you so much for joining today, and let's get started with machine learning. And before I start, I just want to let you know what I'm going to do today. So I will be sharing insights. So I will be sharing with you like how can you get started in this field, and still this field is very young to many businesses, many industry persons, even though many industries are adopting AI, artificial intelligence and machine learning, but like still there are many industries which do not know like how to use or how to leverage AI in their practices. So my job here today is to give you insight like how you can become that professional so that you create impact. For example, I 2 days ago I spoke to someone, and she was in UK, and she did her masters in physics and everything, and she's bringing perspective of quantum physics and quantum computing into her job space. So like that's one of my goal, that how you can bring perspective through ML. So as you see, this is the content which we are going to discuss. And yeah, let's get started. So as you know, like you have heard about this word artificial intelligence, and you know how powerful this is, because mostly what happens is that the machine learning is like a subset of AI, and then another subset of machine learning is deep learning, which has also gained a lot of attention because it surpasses human level performance. So what Sundar Pichai, CEO of Google, is saying is that for the last 10 years, it was mostly about the mobile revolution. Now, the next 10 years, it will be towards AI, and that's very true. From the birth of TensorFlow by Google in 2015, after that, everyone knows that, and of course, the presence of data was also there. But after Google released TensorFlow and Keras like libraries in 2015, then the like data science and deep learning and machine learning really started to gain attention in many industries, and many people leveraged these libraries to build models which can provide accurate predictions. So that's what even IBM's statistics are also saying, as you can see, that 3 in 4 businesses are now exploring or implementing AI in their own business. So this works well when you have a lot of data. So data becomes priority. You need to have data. Without data, you can't work so much in machine learning. And also there are cases where machine learning and deep learning is not always the solution. So you have to decide, say, when you want to use machine learning. So these are the ML forecasts you see. It reports that cognitive ML systems will reach $77.6 billion by 2022, and it's increasing quite exponentially, quite faster. And as you see, there is a hike in salary of machine learning professionals because of the ecosystem which it brings in the industry and the impact it creates. The businesses, all of the businesses are leveraging these data techniques. So you can see like how the salary is increasing. If you are more and more experienced, then you are going to get at least 10 lakhs or 12 lakhs per annum as a salary. And these are some of the hotspots of machine learning in India, which I want to show. Like as you see in Mumbai, it's the highest. Then you have Bangalore, Then in Delhi NCR, I am currently staying in Delhi NCR. So there are several companies in Delhi also, and in the NCR region like Ghaziabad and Noida, which are leveraging data science, data analysts, and all these kinds of job, data engineering. So these are some of the list of companies which I want to show you that who are working on machine learning, and you might have heard about them or you might have not, but I want to clarify by showing you these two slides, this one and this one, these both. So what I want to clarify is that there are a lot of opportunities in machine learning. It is not only restricted to only a few companies, but apart from these companies, there are, I think, total 25 or 26 companies that are mentioned in these slides. But actually, there are more than 80 plus companies currently in India itself who are working on various aspects of machine learning. For example, they are working on like finance sector. They are working on transportation systems. They are working on innovative solutions using natural language processing and computer vision and something like that. So there are a lot of opportunities, and recently I have also started seeing that many students are even joining paid internship programs in these companies and there are various startups also even, and they pay you well if you join there as an intern and gain experience. So what I want to say is that, like, if you are working on projects of machine learning and something like that, if you're working on projects on data science in your undergraduate, you can definitely, of course, show your undergraduate as an experience. So for example, if 2 years of your undergraduate, like third year and fourth year, you have made a lot of progress in machine learning, you have made several projects, you have done, you have completed 2 to 3 internships, you can definitely show those 2 years as an experience. So like one of my colleague, I remember, he is from Hyderabad. He once told that his friend, he got a package of I think it was around 30 or 40 lakhs per annum by a startup only as a data scientist. So, and what he did was that he showed his undergraduate as 4 years experience, because in his undergraduate he started doing data science stuff immediately. So he showed 4 years of experience and he got such a high package in that company. I don't remember that company name right now, but yeah, he got that package. So it will be useful to show your undergraduate also as an experience. So let's get started with machine learning. So the essence of machine learning is that we do not want to program machines because it takes a lot of time. Sometimes we want to automate things, as you know, you might have heard also that AI, machine learning, deep learning, all these things are bringing automation. So that's because there are many lengthy works which we want to avoid doing, and we only want to focus towards the soft skills, which I will discuss later, that as a data scientist and like as a machine learning engineer, how important it is to develop your soft skills, because still this field is very new and not many people understand the things what is going on. So at that time, it's your role as a data scientist or a machine learning engineer to explain these things simple in a simple manner. So that was the goal, that if the machine here means your computer simply, so if your computer learns itself from the data which you provide to it, then you can gain or extract useful insights from that data, some useful inference from that data which you provided. So this is a nice animation which I really like from Edureka, and that's like it's showing you that how the training data is fed into a model, a machine learning model, and then there is new input data provided. Then the ML algorithm runs, it does some predictions. If the predictions are not good, then you again train the model using some hyperparameter tuning. So every model has parameters which you can tune, and if your tuning is successful, then you get a model, then you get a successfully built model. So but I want to emphasize here, like, what I haven't shown you in the slides is another important process, and that is, like, before you build a model, there is a lot of time spent in data wrangling or munging. So data wrangling and munging are same things, and data cleansing or cleaning. So again, those two are same, cleansing and cleaning. So you spend a lot of time to, like, engineer features. So for example, you extract various features, then you perform some feature selection, and what you do is that then you take your data and transform it into something useful, which is the job of data wrangling. So what you do is, for example, I can give you an example. If your date of birth is one of your data feature, it's one of the feature of your ML model, and if it is written something like 12th 12th April 1989, then in another row it is written like 12/04/1989. What your job will be as a data wrangler will be to convert, to transform all those kinds of like inequalities in your data into a standard mapping process. For example, you can convert like 12th April 1989 and 12/04/1989 into 12-04-1989. So that's just a simple example to show you like how the data wrangling thing works, and there are a lot of processes also involved, as I will discuss you further, that only model creation is not the thing. You have to tune the parameters, and but before doing that you need to do a lot of work on the data itself, because you gather data, you aggregate data, then you transform them, then you visualize all your data, your features, you apply statistical methods to know which are the features which will be important to your machine learning model, and then only you train on those useful features. You do not train on all the features, you train only on some most useful features. Otherwise, if you train on the non-useful features, then it's a wastage of time. So that's why all these things come together, all the exploratory data analysis and all these things are done in teams in industries. So it is important to know that there is not only one person who is doing all the jobs. There is a team, there is a whole collaborative process involved in real world industries. But since there are many persons who are working on different aspects, because all the industries have business intelligence specialists, business analysts, and everything, you have to work with them together. And business analysts won't be doing the coding part, they won't know. They will have the intuitive knowledge, they will have the insight, okay, what the ML is for and what the ML should do, even for the product managers also. So what happens is that if you know the field, if you know the field better, then you can communicate well with your team members who are, for example, in a team you will have product manager, you will have business intelligence specialist, you will have business analyst, you will have a data engineer, you will have a data annotation specialist who will specially annotate or label your data. Then there will be a person who gathers data, works on it, analyzes it. Then comes your role, you will build a model as a machine learning or a deep learning engineer. Okay, then there are teams for DevOps, or nowadays the term is ML ops, machine learning operations, who deploys your model. Then there are teams who test it. Then there are teams who measure performance. So you have to be like, you have to be like very communicative. Your soft skills should be so much sharp, that so that you can communicate your knowledge with them. So how that happens is that if you know, if you know the basics of everything, if you know the basics of ML ops, if you know the basics of machine learning, if you know like how data analysis, how data wrangling, all these processes work. Okay, only the basics, not so much detail. You don't want to do a PhD. You just need to know how the things are working as a technical perspective and a business perspective as well. And it makes your job a lot easier to communicate your ideas. So to get started with, so that was insight, like how you should get started with machine learning. So even if you are learning machine learning, you need to have your focus also on the data analysis part, exploratory data analysis, visualization. You should know all these stuff. You should know how to work with various data types, for example, image data, then numerical data, then text data. In numerical data you can have financial data also, you can have geospatial data also, so all those things. And definitely, and as you know, all the machine learning stuff, machine learning itself, the word is a misnomer. Okay, so it's a catchy title created by IBM in the year, I forgot the year. They only created this title, machine learning, because it sounds very fancy. But actually, what happens is that you mostly use statistical techniques, statistical and linear algebra and probabilistic techniques to actually learn your data. So since the computer is a machine, and you work on computer and the computer does all the processing, so why they call it machine learning. But if you want to call it more accurately, then I would say it's like statistical learning, because most of the things which you will learn, they come from statistics. And yeah, that's why there are many programs available in all over the world, like computational statistics, who teach you statistics. And once you learn all those statistical techniques, you can actually go for machine learning jobs, because the primary essence of machine learning comes from statistics. So this slides tells you all the like mathematical fields which you should be familiar with. And the bottom right diagram is actually about optimization. So you should have some knowledge about like how you do optimize your model. Like you know that you have created a model, okay, and now you know that okay, it's not performing well, so how will you optimize it to perform it well? So that's covered in optimization. And calculus is mostly used in deep learning, when you in a deep learning, when you perform techniques such as back propagation for training your neural networks. For that purpose you use calculus for calculating the gradients. So now these are some of the applications of ML. And I would like to also convey that we are going to conduct a workshop on supervised machine learning algorithms next month. So in that, we will be covering like one of these project, like phase detection using support vector machines. So support vector machine is a machine learning algorithm. As you can see, the green dots and the blue diamonds. Okay, so consider that the blue diamonds are like the images of dog, and the green dots are images of cats. So what a support vector machine does is that it creates two margins, two high maximally separated margins from the last data point. As you can see, the last if I can just show with my mouse, it's this green dot and then this blue diamond. So these data points which are maximally separated from each other, they are your support vectors. When you have that, then support the job of support vector machine will be to create this margin, maximum margin, and have this hyperplane, have this line drawn in the middle of that maximum margin, which separates those data points optimally. So that's the job of a support vector machine, since it uses these support vectors. So that's why it's called a support vector machine. Again, machine is like your computer, nothing else. It's just a model, it's just a mathematical model where you feed your data and it trains, and then it finds this boundary. So that's one of the models. So at this point I would like to like ask, are there any questions, Ayush?
Oh, pardon?
Hello. Yeah. Ayush,
What did you say?
are there any questions?
No, not till now.
Okay. Okay. So let's move forward, and then another important application. So okay, another thing is that this face detection and all these stuff you have already seen in like Facebook using them and everything, and they are also used for surveillance purposes. So if you learn these techniques, then it helps you to gain some skills which you can leverage in the industry where you are going. So, and also it creates a perspective of like thinking about things from a different perspective. Another thing is you have already know that in uh, in medical science, deep learning machine learning models are used to predict various diseases, to classify various diseases, and this is one of the projects which we are going to also cover in our workshop, which is cardiovascular disease classification. And this is based on various factors, as you can see from the image. What are the risk factors which increases this disease of cardiovascular, and we will be classifying this using the random forest. So again, consider random forest as a like a collection of various trees, because you know what is forest is a collection of trees. So each tree makes classification after seeing your data, and after it sees your data it makes classification, and then a majority voting happens, and after that voting it decides that whether it is classifying it as a label 0 or label 1. So for example, label 0 can be no disease, no cardiovascular disease, and label 1 can be like it has found some disease, so something like that. So that's the job of a random forest algorithm, and we will be covering all these details more. And so this is the thing which I was talking about. Okay, someone has raised a hand, so let me see. Mm, okay, someone is saying support vector machine. I can't understand. Okay, so let me go back and explain you. So what is happening in support vector machine is that if you have data points, you need to identify what support vector machine does is that it separates these data points, these support vectors, by a maximum margin. Why maximum margin? You need to have a maximum margin so that they do not overlap, so that your predictions remain accurate, so that your classification should not classify cats as dogs or dogs as cats. So if you consider these blue diamonds as dogs, and if you consider these green dots as cats, it should not identify cats as dogs, isn't it? It's just a simple example. There can be more complex cases, but cats and dog example is one of the most famous ones and one of the most easier to grasp in. So you are developing a classifier which can separate these two. So that's why you need to have a maximum separation among those data points so that they don't overlap with each other. If they overlap, that means there is a chance possibility of error, that your dog data, that means for example, if these blue diamonds were in this spot, in this space towards the green ones, then there is a chance that the cat data will be recognized as dog. So you do not want that to happen. So that's why that is what support vector machine does. It's that it creates this margin and separates it so much, like it separates it, like keeps them far apart. It's like, you know, pushing all those data points, like all those, first of all it extracts all those features, and after extracting all those features, it's trying to like classify one data onto one side and another data onto another label side. So for example, if this side, for example, green dotted side is the 0 label and it has cats, and if it found that it has extracted the features of a cat, then it will try to separate all those features from the dog's features. So for example, cats have a like something, for example, like cats have like a for example, triangular ears, okay, and dogs have flappy ears. So if it extracted that feature that I have flappy ears and then I have triangular ears, so it will try to separate those features as far as possible. So it's like pushing all those data features apart so that it can, so that the support vector machine can classify them easily. So it's like a pushing apart stuff happening. So is that cleared? Who asked this question? Um, is that clear? Who asked that question? I forgot. So somebody asked
Yes,
about support. Is
he's
it
telling
clear?
yes. Yeah, yes, yes.
Okay. And we will be covering more of this in a workshop. Actually, its a support vector machine was very famous until like from, I can say you, from 2000 to 2009 or 10. It was very famous. After 2010, graphic processing units started to take over, and because of that deep learning became famous. So you can say that from 2010 to 20 and like till now, deep learning is very famous, and before that support vector machine was very famous. So yeah, so let's move. All right. So I think I have explained this slide before. So what's happening is that like you want to develop soft skills to explain a machine learning model to your seniors. For example, how I explained you with the example of cats and dogs, you do, because you know in industry not everyone will be knowing the mathematical knowledge. And so but the support vector machine, if you see, is mathematics. It involves linear algebraic transformations and the process of convex optimization. But not everyone in the industry, for example your manager might not know convex optimization or like statistics in detail, or might be something like that. So you need simple terminology. And this is a nice comic from Google. I highly recommend everyone to read this comic. It's really nice and insightful, and it gives you an idea how you can explain your machine learning model in simple terms to your seniors who do not know machine learning. So that's why I emphasized this in the very beginning of the webinar, that you need to develop your soft skills as well, because even machine learning itself is getting automated slowly. As you know, Google Auto ML is already there, so you do not need so much knowledge about the maths and all those stuff, but you can build models which can give insightful predictions. So so for example you can explain, for example, just to illustrate this fact, that if you are explaining what is machine learning to someone who doesn't knows in industry, you can say that okay, machine learning is something. It is how like it is very intuitive, and you also know it is how like a baby learns. For example, the baby stands, then he falls down, then he again stands, and slowly the baby's brain tries to capture the standing information, that how successfully he can stand and how much pressure he needs to apply on his legs to stand up firmly. So machine learning is something like that. So the baby learns to stand like that. So it trains itself. First he stands, then he again falls down, it makes mistake, then he again stands, okay, and this process keeps on repeating, and finally he knows how to not only stand but even walk and run also. So that is something like the very intuitive understanding of what machine learning is also doing. It is taking data, it makes mistakes, you evaluate the mistakes using a function known as a cost function in your model. And then after evaluating all those mistakes, then what you do is that you tune your parameters in the machine learning model, and see whether it is working correctly or not, whether it is giving predictions correctly or not. So this is something like a baby learning. So very, very similar kind of analogy. So now even machine learning also has some disadvantages, and I would like to point some of them. So whenever your prediction is like your prediction suffers if you do not have enough data. So that's one of the condition with machine learning, that you need to have a lot of data, and also you need to have not only data but you need to have quality data. So for creating quality data, all those data wrangling, visualization, analysis, all those data engineering, all those things which I mentioned earlier, all those things come into picture to create quality data. And you need to overcome bias also in data. So bias, you suffer from bias when there is a imbalanced data set. So for example, you have more images of dogs than cats. So your number of images in cats is less, and number of images in dog is more. At that time, what the machine learning model will do is that it will only predict the dog very well, and it will make mistakes in cat because it was unable to extract features of the cats, that it has a pointed nose, or it has a like a triangular ears or something. It only captured the dog's features like flappy ears more, because the dog's data was more. So that created a bias. So that's why data imbalance is also taken care of during the data analysis and exploratory data process. Then another thing from the industry and business perspective which you think is that machine learning models are interpretable models, because mostly they are based on statistics, and statistics is a like it's a very old mathematical field, as you all know. So since and from statistics you can actually derive a lot of useful insights, and those insights actually help you to make business decisions in real time industry. So, and it is sometimes also possible that even if like for example, it happens that like if one of your features which statistics finds it useful, but in the industry they do not find it useful, for example your seniors do not find that feature useful, they can even drop it, even though your machine learning model gave a quite high accuracy of 95% using that feature. But if in real life it is not so important, then those features can be dropped. So even the data science process is also all about decision making process in real life industry. So in industry you work like this only, you completely do not like depend on the data science process. You take its help, you gather insights, derive insights from those models, and then ultimately it's up to the decision making process whether to use those features of data or not. Then another disadvantage is that algorithms do not work together. So one algorithm at a time, and many times it has been seen in industries that very basic statistical models such as linear regression also gives you very nice accuracy and very nice statistical insights which you can use for your business processes or your industry job. All right, and there is a issue of ethics in machine learning, which you already know that it happens because of the bias present in data. So whatever data you provide to the machine, it will act according to that only, because ultimately all of these are uh, mathematical, all of these are statistical learning tools. So the better quality of data you have, the less imbalanced data you have, the better it is for the model to make less mistakes, and it takes care of the ethics as well. And model and the deployment scenario, we will discuss a bit about that. It's a very large field. I cannot discuss it so much in detail. There are a lot of things which happens. So but one of the things you do for I just want to mention this, that if you have a lack of data, then there is a lot of research going on today, like how can a machine learning or deep learning model learn from less data. For example, it is something very analogous to our human brain. For example, if you see a image of dog only once in your whole life, you will know that it is dog. You will never classify it as cat. So what happened is that your brain learned immediately in one shot that yes, it is a dog and it will remain a dog. It won't become a cat. So we are now, so there are research going on today in the academia and industry both, on a few short learning. So in few short learning, you gather these insights, like how if the data is less, if you have less data, then also how can you like develop architectures which can actually extract useful features and learn only in few shots. So those are called like few shot learning, one shot learning, zero shot learning, k shot learning. So I highly recommend trying these, like searching these terms, like few shot learning. They are very interesting, and they give you some insights like how you can use these models, which are not entirely like large data dependent. Rather, like you should provide them small amount of data and they will learn quickly, just like human brain. So now, of course, without the deployment, your model is not going to be like so much useful. So for example, if you have created all this, like you have done all the processing, all the pre-processing of data, wrangling, aggregation, visualization, everything you have done, engineering, data engineering, and you have created your model also, and it is giving you a 95% accuracy. But ultimately, what happens in industry is that you have to take care of the operations. That means you have to think about deploying your model. So you need to think that now how I can deploy my model in real time, because as you know, all the industries, they are heavily dependent on this stage, and there are software developers are also required for this stage, who give you like all these tools to work with. So as I mentioned before, it's all a team. You do not do work alone, but if you know all the basics about all the things, then it is better, then it is very easy to explain it to others and communicate with your team members who know the similar stuff. So this is the ML ops pipeline, and if you see here, we have in this box, starting from the left, if you can see my cursor, from data analysis, you do model analysis, you perform experiments. Okay, once you like make your ML model through like data engineering, ML model engineer, these are all automated pipelines. So now even these processes are also automated, but still many industries do them manually, because yeah, you can like extract very nice features from these. So if you see the here, the in the source repository, all your code and data and everything is stored, and then what you do is that you serve it in real time. So that's CI, is continuous integration and continuous deployment. So what you do is that you serve your model through various APIs, for example, Flask API, or through cloud services such as AWS or Microsoft Azure. And after you serve them, you monitor them. You test them, monitor them, and see like what are the features according to the feedback. You gain feedback, and then you monitor, and then you test, monitor, deploy. You keep on repeating this cycle, you keep on repeating this process according to your the user feedback which you get. Okay, so someone raised a hand, so I will see. uh, okay, so someone is asking uh, prerequisites of ML. Yeah, so prerequisites of ML, Anshuman, Your mathematics. First, you need to know mathematics, okay, like basic statistics, probability, linear algebra, the things which I covered before. That those things which you need to know. Then you need to know about the data analysis. You need to have some skills in data analysis, how you can do data wrangling using various Python libraries such as pandas and numpy. After you know all those stuff, then you can proceed towards machine learning. But it is always like better to know all those stuff, because sometimes even as you are a machine learning engineer, you might have to do the part of data analysis and the data wrangling and data visualization, all those stuff, and then only you make your model. So so Anshuman, is that clear? Hello?
Sir, I think he's not there.
Okay, he's not there. Okay, okay.
Might
It's
be.
not a problem, but yeah, if someone else has these doubts, then it is important to clear this, that you even need to have like this kind of knowledge which I'm right now showing to you, like ML ops, because many of the industries nowadays are complaining that the candidates who are joining today in industry, they do not know anything about the ML operations. They do not know how an end to end model is built. So you need to know all these stuff, how an end to end model is built, like right from the scratch, like right from all the data analysis, all the data engineering, and making the model and then deploying it on cloud or any web page or in a mobile app or something. So you need to have this deployment experience. And one thing I can assure you is that if you can make end-to-end machine learning models, then it boosts your CV a lot. Your CV looks very unique from others who have only given projects such as iris flower detection. If you know iris dataset, then it is about like classifying flowers, like which is a simple dataset. So rather than working on those same datasets, work on different datasets, combine various data features, which is usually done in real life industry. You need to combine various features, you need to extract features, you need to select features, then you train, and then you deploy using cloud services. So that's the insight I want to give. Like, these are the things, if you know, it boosts your CV. Even if you have only one deployment related project, like where you are doing all these stuff like continuous integration, continuous deployment using cloud services or APIs, Flask APIs, then also only one end-to-end project will boost your CV a lot. Actually, it's a very powerful thing, because this is happening in real life industry, and industries want you that our candidates should have some advanced knowledge about deployment processes. So only model building won't work. You have to deploy it. So let's go. And so that's why what we are going to do is that we are our company Adroitera is conducting workshops to address all these issues, which like most of the people do not have. Even I have also seen CVs of many candidates who do not have the deployment experience, and they only mention the machine learning like model making experience or some data analysis experience, but they do not mention any end-to-end projects where they have like carried out all the operations of data analysis and everything, and then they have made the model and deployed it. So that's what we like cover in our various workshops, and you can follow this link, www.era.academy, for more information. So about the information on our workshop, it will be based on supervised machine learning algorithms, where we will be covering 7 algorithms and 7 hands-on projects on for 2 weeks on every Saturday and Sunday. The timings will be decided later, and that's and the algorithms which we are going to cover is shown here. So we will be covering the supervised part, like the linear polynomial regression. Then we will cover decision tree classification, random forest classification, and I have shown you 2 projects already, like the phase detection and cardiovascular, but there are other stuff which we will be covering. And we will cover all these other algorithms like KNN, then decision trees, naive bayes, support vector machine I have already covered, and we have separate workshop on unsupervised learning where we go into details of clustering and dimensionality reduction. So that's the thing, and yeah, that's it from my side. So any questions, say, if you have, please feel free to ask now. So okay. um yeah, okay, Gaurav, that's a really nice question. So you have dedicated there is one dedicated website for ML ops, which is teaching you which is giving you some nice resources, and I will share it after the webinar definitely with you. If you can just mail me, let me provide my mail to everyone, so that if you have any doubts, you can definitely ask me. There is a ML ops workshop which I will be also doing later. You can join that, Gaurav, if you want. And you have also asked about, and also, Gaurav, I want to say that DevOps is related to like software engineering. So you need to know some basics of software engineering. For example, uh, like uh, like code versioning, code documentation, code modularity, and all those stuff. So that's more for DevOps. But the thing which I mentioned here, Gaurav, it was ML Ops. So it's like a software engineering plus machine learning. So that's like specifically for like deployment purpose. And Bayesian machine learning. Okay, that's more of a research. You can It's more of a research field, Bayesian machine learning. But yeah, what happens in Bayesian machine learning, I can give you a gist. uh, what happens is that if you're training a deep neural network, and for example, if you for example provide it unknown data, still what your deep neural network will do is that it will classify it as a cat or dog. Okay, for example, if you trained your model only on cat on dog, and suddenly you provided elephant, then your deep learning model is confused. The model doesn't knows what is elephant because you have not trained, and still it will classify it as cat or dog. But what happens with Bayesian machine learning, it gives you the power to your deep learning model to say no. Like for example, like if you have trained in cats and dogs, it will do correct predictions for cats and dog. But if you provide elephant, then it will say I don't know. So that I don't know stuff, it creates that I don't know approach in that Bayesian. Then Neville Porus A. Hey Neville, how are you? I've seen your LinkedIn post. It's really nice. Nice to meet you here, and thank you for joining also. Uh, what are the principles intermediate machine and cognitive AI? Okay, intermediate machine learning. I do not understand about the intermediate machine learning. Uh, there are I think you are talking about like some deployment stuff might be. But yeah, as I told you before, like all the prerequisites require you some basic mathematics and basic data analysis, visualization, and wrangling skills. After that only you go for model building. So, and definitely machine learning algorithms you definitely need to know. So purely like mathematical background will help you a lot to understand all the machine learning algorithms. And and for AI, if you are asking about cognitive AI, also AI covers mostly about reinforcement learning. So for reinforcement learning, I would suggest you that you go towards some you learn about like what are Markov models, what is a Markov chain. These are covered in probability texts also, and in statistics books also. And because also hidden Markov model, because these models are actually used in cognitive AI. So for example, I can say you like reinforcement learning uses Markov decision processes. So yeah, you need to be clear with all these stuff, and maths is always necessary. So Sunil is asking how to start learning. Okay, what do you want to start learning? Like, are you asking about machine learning? I think I have answered that question. How do you start learning machine learning? Mm, okay, Danish is asking, do we need to have any previous knowledge? No, you do not need to have any previous knowledge. You just need to have some basic mathematical background. That's it. And then, okay, software and technical knowledge. So programming is in Python, and Python uses various libraries, Faisal. Technical knowledge is more about the mathematics, and software is like more about libraries. Like for example, pandas is used for statistical data analysis. NumPy is used for like creating a matrix of data transformation. You can do that with pandas also, of course, but yeah, you can use NumPy also. And then for if you are asking about machine learning, then we use the scikit-learn library to create all those algorithms, because there are pre-built algorithms and they have been optimized by various researchers. So that's why it is best to use those. But of course, for learning purpose, you can make the algorithms from scratch as well. So that's the thing. All right. So yes, Sunil, actually, I have answered your question about machine learning only. And I have given you like various insights, like what is the process in industry and what the industry wants actually from their candidates. So if you have basic knowledge about all those stuff, which I said you, data pre-processing, wrangling, ML model, yeah, 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 you're welcome, Nival. It's really nice to, yeah, you're welcome, Faisal. And yeah, Sunil. So yeah, what I was saying, Sunil, is that that stuff. If you have, like, if you know all these stuff, and like data pre-processing, wrangling, then what happens is that and machine learning algorithms and deployment, then you can make a like a super duper CV, I can say. Like it's like a powerful CV, you know. Like how do you make your machine learning CV powerful? I think I should conduct a webinar on that. Like you, but I have covered a lot of I have given you a lot of perspective now, that what you should cover. You should cover your end-to-end projects. Okay, make and try to make end-to-end projects. For example, take a data set. Okay, then combine it with other data set, or even if you're not able to combine, then work on those data set, not the like the basics ones. Take some a bit like intermediate level data sets. You can find them on internet by Google dataset search also. You can use that. Sorry. So you can use that and have those data sets with you, perform extensive data wrangling, like do data cleaning process by yourself. Okay, do data wrangling process by yourself, do data analysis, statistical data analysis, then build, then do the feature selection by yourself. Then on those selected features, train your models, test the accuracy, optimize it, tune your hyperparameters, and after that deploy it using a like any deployment service like Flask API in Python, or any cloud like AWS or something. Just try to make your model like end to end. If you do that and put it on your CV, then your CV becomes like a very powerful CV, which no one can reject really, because a lot of like today's candidates, I'm seeing that their CV is lacking the like lacking the software engineering skills, the operational skills which are required for machine learning. So that's very important. And yeah, okay, I forgot Purnima's question. uh, I think I before starting, apart from maths, tech stack up, I think I have answered this, Purnima. Okay, yeah, you're welcome, Purnima. So yeah, any other questions? Yeah, you're welcome, Sunil. And if you have any more doubts, if you want to know more, then yeah, I have given my mail ID. You can definitely contact me directly. So yeah, any other questions? Aditya, which platform? Platform in the sense like which platform is best means like how you can you elaborate, Aditya? Okay, Sunil, any resources for machine learning? Yeah, definitely. What you can, there are like Google has recently released a machine learning crash course, which is available for free. You can learn all the algorithms from there. They are also covering some nice material. Then you can learn then you can also learn a lot of stuff from medium articles like towards data science is like one of the companies which shares nice articles on machine learning, data science and everything. You can read their articles and try to implement them on your own to learn. Okay, Aditya, okay, Aditya, that's TensorFlow is mostly for deep learning. So for machine learning algorithms, we mostly use scikit-learn. So you are asking about deep learning, definitely. TensorFlow is very good for deep learning. Now they have modified it also. You have all like they have like Google has already given all the keras functionality inside TensorFlow. And but yeah, you can use PyTorch even I like PyTorch. I have used PyTorch mostly for my deep learning projects. So and TensorFlow I have used very less. So but it's my personal choice. Yeah, TensorFlow is open source. Yeah, everything is open source. PyTorch is also open source. TensorFlow is open source. No, TensorFlow not for machine learning, Aditya. That's for deep learning. For machine learning, you use scikit-learn. So TensorFlow will be good if you want to build like perceptrons or neural networks. Yeah, yeah, you're welcome, Aditya. So TensorFlow is good for those things, neural networks and all those stuff. In scikit-learn also you have, but yeah, TensorFlow gives you that that optimizers. There are lots of optimizers, and another thing is that since it's been like almost like 6 years now, TensorFlow is there. So lots of contributions have been made to the open source project about TensorFlow. So and then like all those codes are like optimized. So you don't have to create anything from scratch. They have been already created for you and you can use them readily. So yeah, Sunil, so tell me something about your project, like work of the model. I couldn't get what project you are asking, Sunil. Can you clarify? Oh, deep learning model. Okay, okay. So deep learning model, like I have worked on like some like self-driving car projects. For example, like I worked on one project like where you clone your like where you like teach your car like how to drive. So it tries to like mimic your driving behavior. So that was like that is one of my favorite projects, because like in that what you do is that you switch on that simulator, you record your data. It records all your all those like all your driving images, and then you feed that driving images into a convolutional neural network, and based on that it predicts you steering angles. So on the basis of steering angles it tries to like mimic like how it should turn left, when it should turn left, when it should turn right, so something like that. Yeah, Aditya, as I mentioned before, I have mentioned this deep learning is a subset of machine learning. So remember that neural networks is a machine learning algorithm. But since neural networks started to like gain so much popularity because they were more like they were much more better in predicting many things, and their accuracy was very high, so why people like separately like created a separate branch called deep learning, which is entirely based on neural networks. So neural networks is entirely based on linear algebra and calculus. So so it's like a subset. Yeah. You're welcome. You're welcome, Aditya. So Ayush, I think, hello.
Yes, sir.
Yeah, Ayush, I think there are not many questions now. I think I have covered all the aspects.
Yeah, I also
And
believe the same. And thank you very
mhm.
much, sir. It was really a pretty
Yeah,
much
thank you so much. Yeah.
insightful session on ML. And guys, I have shared the feedback link as well as the mentor profile LinkedIn link. So if you want, you can connect with him over LinkedIn as well if you have any doubt, or you can fill the same in the feedback. So anything, sir, like before signing out, the last word which you want to tell the audience out there?
Yeah, so what I want to say is that like it's important to like know that the field is quite big, and what makes you separate is that if you have end-to-end projects on machine learning, then definitely it creates a lot of value uh, on your profile, because you will be the unique one who has deployed like a model from end to end by carrying out all the analysis or like optimizing it, tuning it, and everything, which is done by a team of people. So what industries require is that one person should, unfortunately this is true, that industries require those people where one person can do the work of like five people. So unfortunately that's true, but ultimately in industry also there are separate teams for everything. And definitely you collaborate with your team, and once you like go through all these processes of total deployment, creating end-to-end models, you know how to, because you know now the how will you communicate with your team. For example, if one of your team member is in deployment and you have deployed a model, and then you can help that other team member. So that's more of a soft skill side. So since, as you know, everything is getting automated, in future soft skills will be like will matter a lot. Okay, so Nivel, what is it? Okay, that's Nivel, that's like I think that's a little, that's a question which like I am a little biased because I have studied from foreign university. So but yeah, I will never say that yeah IITs and NITs are not good enough or something. Okay, they are always the best, because I haven't said about my background. I am from signal processing background. Okay, like electronics and communication. So in communications, particularly, I focused on wireless communication and signal processing. So my journey is like I went to IIT Kanpur several times for like studying wireless like signal processing courses, and doing some like research based projects on signal processing. And from there only I started my machine learning journey, because even they were also started like they also started to use machine learning. So I will never say that yeah, even IITs are also excellent. They are also excellent to do post graduation AI and ML, definitely. And I have learned a lot. I would rather say that's my personal opinion, that I have learned a lot from IIT Kanpur during my signal processing journey. So yeah, definitely it's really good. And the professor under whom I learned and everything, he's still conducting courses on wireless communication on 5G technology, which I also studied 5G. So like I studied about 5G technology such as massive MIMO systems, uh, antenna subsystems. Okay, how will you perform signal processing in antenna systems, and like yeah, and all the and the wonderful thing is that all the mathematics which I learned at IIT during those signal processing courses, actually helped me a lot to gain knowledge on machine learning, because even machine learning uses the same mathematics, the same statistical techniques which is used for decision making and estimation in signal processing. That same kind of stuff is used in machine learning as well. So yeah, it was really good. So I hope that I answered that question. And Sunil, yeah, definitely I will share my LinkedIn. I do not have Instagram. I have only one social media, that's LinkedIn. You cannot find me on Facebook or Instagram, or I have Twitter, but I do not use it. You're welcome, Nimal. I am really glad that you joined. Okay, and I hope that it was insightful, and I might have missed some points here and there, because it's quite vast, and definitely you do not need to remember all the stuff. You just learn as you go, or you use them when you require them. That's the main thing. So so Ayush, I think
Yeah, I
I
think
think
like
we can
we
we
can
can
wrap up
wrap
the
up.
session.
Yeah,
Yeah,
yeah.
definitely. So, guys, go through the feedback form. Like, I'm here for 2 more minutes. Answer if you want to sign out, like you can. Like, I will like I will be wrapping up the session in 2 minutes. Thank you very much, sir. Goodbye, sir.
Thank you so much, Ayush. Please say thanks to Pramit sir also, and MFL Educlub Sanaya,
Yeah, definitely.
for conducting this webinar and inviting me. It was really nice.
Thank you, sir. Same here.
Thank you. Yeah.
Guys, do go through the feedback form because a survey form is also attached to it. So it is very important for us to understand your feeling or like what you want to, which will help us to bring such more session in coming future. So kindly go through it. Thank you, Neville. And guys, yeah, goodbye, good night, and don't waste your time. Be productive.